This is Mr. G, and this is our warm-up for today's lesson. So pause the video right here, give this problem a shot, come back when you think you have an answer. We're going over 3, 2, 1, let's go. So we got to find the intersections of f of x and g of x, and we can use a graphing calculator for this problem, so that's what I'm going to do. I'm going to hit y equals and plug in my two functions, so 0.3x squared, and the second one is negative, and then it's an absolute value. To get to the absolute value, I have to hit math, go to number, and hit enter for the first one, which is an absolute value. Then x minus 6, get out of the absolute value by hitting right, plus 8. Then graph it. Let's see what we're looking at. There's our parabola, there's f of x, and there's the upside down b, the absolute value function for g of x. All right, now we got to find the intersection. Remember, whenever we're trying to find something on a graph, a good place to look is second calc. Second calc to get to the calculate menu. And we're looking for an intersection, which is number 5. You can go down and hit enter, or you can just hit 5 to get there a little bit quicker. Now it's asking us first curve, second curve, and guessing, but all we have to do is move kind of close to the intersection. That's the first one I'm going to find. Now you'll notice I'm not perfectly on it. I'm a little bit to the left. It doesn't matter. As long as you're anywhere close, it'll work. Now I hit enter, second curve, hit enter, guess, hit enter, and now we're done. We're done. We know we're done, rather, because it says intersection. So the first intersection was negative 1.41, we'll round it to, and 0.59. We'll round to the nearest hundredth, 2 decimal places. Now let's do the same thing to find the second intersection. Second, calculate 5 for intersect. Now I'm going to hit right till I get close. Moving very slowly, but we're getting there. That's probably close enough. Enter, enter, enter. And the next intersection we got was 4.74 rounds to, and 6.74. So those are the two intersections of these two functions, f of x and g of x. Let's take a look at our objective. Today we're doing chapter 4, section 5, and after today we should be able to solve quadratic equations by using graphing calculators. So we're using graphing calculators to solve these quadratic equations. So this is our fourth and final method for solving quadratic equations. We talked about solving, well, I guess technically it's the fifth, because we talked about square roots, just getting x by itself, then factoring the quadratic formula, completing the square, and now we're going to talk about using the graphing calculator. I often don't count the square root as a method because, that you just get x by itself, it's not too hard. But today we're going to talk about how we solve with a graphing calculator. Now here's the key to solving by a graphing calculator. I'm going to turn this off just so we don't have it up there sort of distracting me. This is the key. It's the most important thing to write down. The real solutions of 0 equals 1/2 x squared minus 4x plus 1 are the same as the real roots of y equals 1/2 x squared minus 4x plus 1. So in this sentence, there's really two main sections. There's the first half and the second half, and they're almost identical. It's saying the real solutions of 0 equals 1/2 x squared minus 4x plus 1 are the same as the real roots of y equals 1/2 x squared minus 4x plus 1. There's only two changes from the first half to the second half. The first is that it went from a 0 equals to a y equals. So this whole time we've been solving quadratic equations, most of the time we want to get 0. We want to get it in standard form so that everything's on one side of the equation and we have 0 equals that. But here, we're turning that 0 equals into a y equals. All right? And the other change is that it changed from real solutions to real roots. So it's saying the real solutions of the equation are the real roots of this function, y equals blah, 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 that whole expression. Now we got to remember what real roots are. Real roots are the x-intercepts of the function. Another word for that are the zeros. So real roots, zeros, x-intercepts, they all mean the exact same thing. Now after looking at this, I wouldn't blame someone for saying, but wait, why? Why would that be the same? Why would the real solutions and the real roots be identical? Why would they match? To answer this question, to see why it makes sense, to see why the real solutions are the real roots, we need to understand what solving means, and we need to understand what a real root is. So let's take a look at what solving is. So if we had to solve 0 equals 1/2 x squared minus 4x plus 1, that would mean we're trying to find an x value that makes the equation true. Another way to look at that is, okay, we're trying to find an x value where when we plug this x value in, it equals 0, because that's the only way the equation is going to be true, is if this part equals 0. So we're looking for an x value that when we plug it in will give us a 0. We'll make the expression equal 0. Now let's keep that in mind as we remind ourselves what real roots are. So first, or rather, we already reviewed what they are. They're x-intercepts. They're zeros. But okay, if we had a graph, where do we find the real roots of a function? Well, if the real roots are the x-intercepts, they're going to be somewhere on the x-axis. Like all those points right there are real roots, which means these real roots are all going to have something in common when it comes time for the ordered pair. All of these real roots are going to have a y value of 0. We don't know what x is. X could be different for all of the real roots, but we don't move up or down from the origin, which means the y value is 0. So essentially, it's going to be something, some x value, and 0. Again, could be 5, could be 7, could be -3, but it's always going to have that y value of 0. So now let's put these two things together. So if we're looking for the solution of this equation, we're looking for an x value that gives us 0 when we plug it into that expression. And if we're looking for a real root, we're looking for an x value that gives us a y value of 0. That's what an ordered pair means. Like if we have an ordered pair that's something 0, that means, okay, whatever we plug in there, whatever domain value we give the function, will give us a y value of 0. Now, I don't know about you, but those both sound really, really familiar. Or excuse me, they both sound really, really similar. That's the word I was looking for. So essentially, if we want an x value that gives us a y value of 0, if I plug in the x values, that's going to take this y and turn it into a 0. Which means we're going to get the exact, let me do this in a different color. We're going to get the exact same equation we had up here. So by finding the real root of a function, we're essentially saying, okay, we know a real root always has a y value of 0, so we're trying to solve this equation. So real root, you can almost imagine it as rewriting the function, or rewriting a function in terms of a quadratic equation in standard form, where 0 equals the quadratic expression. So hopefully that makes sense, but I can understand some students saying that, oh, all right, I sort of get that, Mr. G, but why bother? Why bother? I mean, we already know how to factor. We know how to use the quadratic formula. We covered completing the square, even though no one likes that method. So why are we bringing a function in here? Well, because finding a real root with a graphing calculator is easy once you know how to do it. Let's take a look at example 1 to show you how simple this is. So we're going to solve the equation x squared equals 2x plus 3. I'm going to rewrite that down here. And we want to round our answer to the nearest hundredth. Now, the first thing we need to do for almost any method of solving a quadratic equation is to get everything on one side. So I'm going to subtract the 2x and the 3. Now, if you want to do it the other way and subtract x squared, that will work as well. But in general, I like to have a positive first term, but this is actually the one method where I don't mind having a negative in front, but we'll deal with that later. So this becomes x squared minus 2x minus 3 equals 0. So to solve this, we just need to find the real roots of the equation x squared, or excuse me, of the function x squared minus 2x minus 3 equals y. So let's go to our graphing calculator. I'm going to turn it back on if it'll listen to me. There we go. I'm going to hit y equals, and then I type in what y equals. X squared, where's y equals go? Y equals, there we go. Okay, let's clear out all that. Clear. Go back up, and it's x squared minus 2x minus 3. Then we hit graph, and we get a nice parabola. Now remember, the real roots are on the x-axis, so we can see two real roots right here. So I'm going to go to second, calculate. That's where we go to find things in our graphs, or at least that's one place we can go. And we're looking for the real roots, which are the same thing as the zeros. So I'm going to hit 2, or you can go down and hit enter to get to the zero tool. And now it's going to ask us left bound, right bound, and guess. So first it's saying, okay, give me something like, how do I want to say this? We talked about this in a previous video, but let's just sort of remind ourselves how to do this. Whenever the calculator is using, or whenever we are using the 0 tool, the real root tool, the calculator essentially says to us, okay, sure, I'll find the real root for you, but you got to tell me where to look. I'm not going to look on this whole function because there might be more than one real root. I'm just a stupid calculator. I might get confused. So it's up to us to focus the calculator where we want to find it. That's where the left bound, right bound comes in. So right here, about right there. That's about as close to the real root as I can get. I can't get exactly on there, but that's essentially where the real root is. What we need to do is give the calculator something to the left of it. So I'm going to move to the left. It doesn't have to be that far, but I'm going to hit enter right there, and then an arrow pops up. That arrow is essentially saying, okay, that's where I'm going to start looking, and now the question changed to right bound. So I can move right till I pass the real root. You have to pass the real root. Now I'm on the right of the real root. I'm going to move a little further, or a little farther rather. It doesn't have to be that far though. I hit enter, enter again because I don't care about guessing, and it gives us the first zero is -1, 0. Now I'm not going to write down -1, 0 because remember our original question was asking us for the solution to this equation. There's no y's in that equation. So all I'm going to do here is say, okay, x equals -1. That's our first solution. Then we do the same thing for the second real root. I hit second, calculate 2 for the 0. Go to the left, keep going, keep going. That's close enough. That's to the left of it. I hit enter. Then I move to the right of our second real root, hit enter again. Don't care about guessing, so I hit enter a third time, and we get the 0.30. But again, we don't care about the y value here. All we care about is the x value. So x equals 3. Those are the two solutions to our equation. Let's do one more together, then I'll have you try one on your own. So here's example 2. Got to solve the equation 2x squared minus 8x equals -5. Now let's make that look a little bit more like an x. Okay, first we need 0 on one side, so I'm going to add 5. And that becomes 2x squared minus 8x plus 5 equals 0. Now to use a graphing calculator, we're just going to plug that into our y equals. Now I know in the last one I wrote like, okay, all of that equals y. You don't need to do that every time though. I was just sort of showing my work. Now I'm just going to take that and plug it in. So clear the old one. We get 2x squared minus 8x plus 5. Hit graph. Let's see what we're looking at. Okay, we've got our parabola. Now we've got two real roots. We go to second, calculate 2 for the 0. One of the zeros is right there on the x-axis. I'm going to hit left to give the calculator a point to the left of it. Then I'm going to move right to give the calculator a point to the right of it. Hit enter, and we get a decimal. So we're rounding to the nearest hundredth. That's 2 decimal places. So x equals, what's the x value? 0.775, so it's 0.78 it rounds to. And there'll be one more real root because I see another x-intercept. Second, calculate 0. Move to the left. I'm going to hit enter there because that point is to the left of our second real root. Move past it to the right, hit enter, enter one more time. And we get, oh, okay, I'm happy this happened. So the x value is 3.22 it rounds to. But the point we got, I'm going to write this here. It gave us 3.22, and, oh, okay, let's write it so we can read it, jeez. It gave us a 3.22, and then it gave us a 1e -12. We talked about this in a previous video when we were first learning how to use graphing calculators. Whenever you see an e and a negative number after it, when you're doing these types of problems, finding a real root, that essentially means 0. So the point that they actually gave us was 3.220. I'll be honest with you, I'm not 100% sure why the calculator does this sometimes. I feel like it's sort of like a rounding error or like a coding mistake or something like that. But just know, whenever you're doing this type of a problem, if you see an e and a negative, just remember that's a 0. So our final answer here, x equals 0.78 and x equals 3.22. I guess there should technically be approximation signs since we had the round. Sometimes I forget about that though. But yeah, technically it should be approximate. Okay, last one for this video. Try it on your own. So I want you to solve the equation -0.4x squared plus 2 equals 6x, round to the nearest hundredth. We're going over to 3, 2, 1, let's go. First, let's get y by itself, get everything to one side. There is no y. So it's -0.4x squared plus 2 equals 6x. I'm actually just going to subtract 6x here. Now, if you did it the other way by moving everything to the right, that's okay. You'll still get the same answer as me. Your graph might look different though. So it's -0.4x squared minus 6x plus 2. Now I know in previous videos, I'm sure I said this at least once, in general, I like to have a positive a value, a positive lead coefficient, but this is the one method where I actually don't mind because I'm just going to type it into the graphing calculator. I'm going to clear all that. So -0.4x squared, there we go, minus 6x plus 2 plus 2, and graph it. Let's see what we get. Now, if you moved everything to the other side, so it's a positive a value, you probably got something that looks a little different. Oh, geez, I can't even see everything. So let's zoom out. So I'm going to hit zoom, go to zoom out, and remember, you have to hit enter once you're looking at the graph to zoom out. Okay, now we can see everything. So now, like I was saying, if you moved everything to the other side of the equation and got a positive a value, then you're probably looking at a picture that looks something like this, something like that, something that's concave up. But remember, the function here doesn't actually matter. What matters is the real roots. What matters are the real roots. So we're going to hit second, calculate 0, go left till I'm to the left of the first real root. That's to the left of it, hit enter. Go right till I'm to the right of it, enter one more time, so it'll give us an answer. So our first real solution is x is approximately negative 15.33, if I'm rounding correctly. Yep, 326 rounds up to a 0.33. Then the second one is going to be, let's see, second calculate 0. And I move over, that's to the left of my second real root. I'm going to hit enter. Then I move till I go into the negative part of it and hit right, hit enter one more time. And let's see what we got, 0.326. So that's going to round to 0.33, 0.33, yep. And those are our two solutions. Hopefully that's what you got on your own. Before I give you an assignment, there's one last thing I want to talk about. We just have 3 examples, and for every one, we got 2 solutions. Do you think there will always be 2 solutions? Well, hopefully you're saying to yourself, well, no, probably not, because, I mean, there were plenty of times when we had quadratic equations before where we didn't get 2 solutions, where we got 0 solutions or 1 solution. So just because we're solving them by graphing now, doesn't mean that suddenly that's going to go away. We're still going to have 2, 1, and no real solutions. So let's talk about how the graph is going to look if the number of real solutions is 2. Well, okay, there need to be 2 real roots, 2 x-intercepts right there and right there. And if the number of real solutions is none, if there's no real solutions, then our parabola will be completely missing it. There will be no point crossing the x-axis or even touching the x-axis. And if there's 1 real solution, then that means our parabola is touching the x-axis only once. Now, the only way that happens is if the vertex of our parabola is touching the x-axis. So this is what it would look like. So if you're doing, if you're ever solving by graphing, don't think it's always going to be 2 solutions. The first thing you should do is look, okay, how many real roots, how many x-intercepts do I actually have? And that'll tell you how many real solutions you're going to end up with. All right, your assignment for today is practice 10-7. That's a worksheet you can work on. Hopefully I'll have some time to post the answers, or at least some of the answers, to our Google Classroom so you can check yourself to see how you're doing. Hopefully this all made sense. If you have any questions, let me know. Enjoy the rest of your day.